Awesome, Pete. Thanks, mate. Hello, everyone. Welcome to the session today. So, as Pete rightly introduced, we're going to talk about scale and the various scaling mechanisms we can employ to help sort of right-size our applications, but also the resources that underpin those platforms as well. So let's get started. I'm going to hit next, and there's a big ugly mug of me. So I'm Berkey. I go by Berkey because my mother calls me Anthony when I'm in trouble, right? So Berkey's what everyone gets to know me as. That's easier to self-style myself that way. So I'm really pumped today. I've been at HashiCorp for nearly 2 years now, which puts me as part of the old guard early in the company. And then from that was before I spent 7 years in the field of VMware with NSX. So let's talk about today. What about scale? Right, scale is one of those things that get thrown around quite casually, which has a number of different meanings for different people, right? And so I wanted to go through today various things that impact scale for applications and businesses, the impact that scale has on deployment times, on application right sizing, the cost of running applications, and then how we can neatly solve some of the challenges posed in this problem space. And then I'll demo that off. So let's talk about the engineering term and the factor of safety. Traditionally, if you look at an application, you go, Burke, I need to deploy an application. For me, it revolves around web database middleware tier. You'd only deploy it for peak usage, right? Just in case. The idea that I want to ensure that I'm going to deploy it for peak usage. If it's like a large recommended sizing, I'm going to do large, and I might add 20% on top, right? This is traditionally true of on-premises, but more so we find it with cloud as well, that mentality of just in case I need to provision it. So I'll provision it for like the Christmas Day sale, Christmas sales, the Black Friday sales, if it's a retail application, or I might have a statistic application and I have a once in 4 year event I need to scale for. I'll just leave it on, always full, because why not, right? And the result is this excessive consumption of resources that on average, you would have event-driven requirements. In the quiet times, it's off or very minimally used. In the busy times, it's it's full bore, right? Full tilt boogie. And more often than not, you're catering for this higher level watermark and using and wasting money and resources. And even in some cases, you'll have applications that don't perform well when they're over resourced. Think of CPU and NUM allocations and things where you have over too many CPUs, and it's a single threaded application, right? What's the point? So that is the factor of safety that ends up being overbearing on our resource usage. Without getting too much into the business side, the notion here that Gartner calls this out as something as one of the bigger trends is cloud wastage this year alone was $17.6 billion, right? And look, it's not really relatable to most of us, the terms of money that is, but $100 here, $1,000 there, $10,000 there on the wrong size instance, right? It might be only $4 a week on an instance, but all of a sudden there's 20,000 people doing that. Some people are getting rich off this, and we're just wasting our money, right? And the reality is that right-sizing applications from the start and having things that can solve this for us can help alleviate some of this cost, privity cost, and even wasted money. Like $6 billion is insane, but even $6 billion is insane from oversized resources, let alone from idle resource, right? So we've all heard as techs and business owners and application owners that just scale it, right? Just size it right, Berkey. And I sat there and I go, okay, well, what does that mean to me? How is this a sustained number of increased requests? Is this a spike or burst of increased requests? What about the underlying platform resources? I might be able to scale something and add another instance of it, but do I have enough platform resources? Can this be done automatically? And can do it in a response-driven fashion? Can it be data-driven? Like only when being used do I scale out accordingly. And then afterwards, when this need for peak is gone, do I right size myself back to normal? Do I have the smarts to do that? Am I going to do that? And these are challenges that come in with you just say, I want to scale this out, right? Let alone you're dealing with stateful applications, stateless, you just turn some knobs. But how do we do this in a right way that matches what we see in the data-driven side and then what we see like in the real world? So what are our options today, right? How do we scale platforms today? Now, depending on the deployment type, you have the ability to add more memory or CPU or add more reservation of these CPU resources. Do I add more nodes to a cluster? If I'm using a scheduler like K8s or Nomad or OpenShift, do I just adding more nodes to the cluster for more resources to then be consumed? Am I taking advantage of cloud autoscaling groups on a metric-driven threshold, deploy something more or remove something from that group? Do I factor in any system metrics into this? Am I doing, oh, you know what, Berkey, I think it's going to be 64 gig of RAM today. That's what I'm feeling like, or spin a lucky board, right? Am I doing that human guesstimation? Or do I just look at the recommended docs and go, oh, look, we're a unique snowflake. I need to oversubscribe this because of our reasons, right? All of these play into a factor of how we scale today. Now, through organization process, through people like set and, there are many companies out there who set something and will have to forget it because that's the way they work, is oversubscribed from day one. But is this the right way? How can we start solving these problems? So I want to introduce the concept of straightforward and smart scaling and talk through some of these problem spaces. So there are three types of scaling that I want to talk about today. One, horizontal application scaling, the notion that jobs can be scaled out with a minimum and maximum defined count. Go from 2 web front ends to 10 web front ends, back to 2. Right? That's what I call horizontal application scale. Vertical application scale, changing resources of individual jobs or individual applications based on their consumption. Okay, this particular application has 2 gig of RAM and 2 CPU, but it's been hitting at 80% threshold at this watermark. I recommend we should increase it by 2000 megahertz and 64, by 6 gig, right? Or 64 meg or some arbitrary integer. Then there's the horizontal cluster scaling where I can add, if I'm using a scheduler or a platform, add more nodes, add more resources for my applications to consume, right? Hot adding those resources. Nomad shows a way of approaching this in a pragmatic sense that is designed for whatever type of scaling problem space you encounter. If it's one of the ones we discussed, horizontal app, horizontal cluster, or vertical application, the architecture behind our autoscaler plugin allows us to provide a consistent way of data-driven scaling that removes the human process. That's the fundamental tenet behind this. And so what we do is, in this diagram shows at a very high level, is we define a number of things. We define our plugins, so autoscaling plugins that will say what type of metric do I want to look at, what system am I looking for the metric from? Is it Prometheus? Am I pulling it from another a Datadog or something such like that? What plugins? So what's the target of the scaling group? Is it am I doing an application? Am I doing a autoscaling group? Am I changing the count of something? And then I'll define a strategy. At what threshold? Is it CPU, memory, load balancer connections, number of closed connections, number of hung connections? All these metrics and data that I pull from my application at any way to monitor it through these tools, I can leverage to give data-driven things. So real traffic, not synthetic load testing, but real traffic. Can observe these metrics and then dictate an action that Nomad will take. So let's talk through these problem spaces. So horizontal. Horizontal scaling here shows off the scale count of the notion of n-scale workers. Horizontal scale provides us the additional copies of a workload. So think of it like additional pool members behind a load balancer or additional things to provide that additional absorbing the connection, right? It might be one web server moving to 10 or 10 to 100, right? And that can be based on that. Well, a factor of this is considering the application stack and the implications of your middleware tier. Because you open up the floodgates, can the rest of the infrastructure handle that? But this idea is to handle additional connections. Vertical scaling. This ensures the right amount of resources. So if I start with a large application here, and I've done that, and then over time, the average usage is like 1/10 of what I've subscribed to it. Maybe I can look at scaling this right accordingly, and it will analyze that data, make a recommendation through the dynamic application sizing, and then recommend that deduction or changing from 2 gigahertz to 1 gigahertz to 512 meg to 128 meg, because that's what it needs, right? And then based on that data at a specified polling interval, recommend a new change. Okay, Burke, you have the last 24 hours. This is the average trend. We should increase it accordingly. Dynamic application sizing as part of Nomad Enterprise provides us the ability to do on a per application basis, provide scaling policies relevant to the application, right? So I can say for app 1, I want to do horizontal scaling, and I can see here that I start with a count of 2 in the first green box here, and then I have a scaling. The minimum is 1, the maximum is 10. So based on the policy I define, if I trigger, let's say, the CPU threshold at the 98th percentile, I can say, if I trigger that, you can scale this job out, and it will make a change to the job file and make the scaling up to 10 based on what it needs to have it to make sure it drops out of that 95th percentile. So on demand, I'm already doing that horizontal app scaling for those front end, for those stateless workloads, which is super handy. In this case here, it's Redis. And you can customize all of this, the frequency of it, how often it checks, how often will it do it for you, and if you want to notify other systems, right? So it's pretty handy in that sense there. The application sizing can also make a recommendation. So if I'm doing dynamic application sizing for vertical application scale, what Nomad can do is, along with these policies, is say, hi, this is the recommendation I've made based on the data. So currently I have an example here of a workload that has 3.2 gigahertz assigned to it and a gig of RAM. On average, over the last 24 hours, it's used 800 megahertz of RAM. That difference is 75% less. And as a result, I could save myself not having to provision that much resources, right? And think of that over one application, you might go, oh yeah, okay, Burke, that's fine. But over 10, 20, 30 jobs or potentially application workers doing that, all of a sudden you can start seeing the substantial savings. And these recommendations are made automatically from the data provided from the application to be viewed by the user, right? And then you can accept that or deny that, because we don't always do it. We don't want to become Skynet and resize vertically applications on demand. So we do prompt you here for a human interaction for vertical application scaling. And you can see here the checks that we do, right? Here's CPU scaling and memory. I can say the strategy is based on a percentile, and on this integer, if I'm seeing a 98th percentile hit in my data metrics, I will trigger that frequency, and it will do it once every 10 minutes. Just a bit of water there while I freshen up. And then I have the final one, which is expected, but something that people would think of, well, how do I manage this here? Cluster horizontal scaling, or horizontal cluster scaling. Increasing and decreasing the nodes through scale out and contraction and demand-based scaling. So let's say I start with a Nomad cluster of 10 nodes, and I'm using it at about 75%. Let's say some applications horizontally scale themselves, they vertically scale themselves, and Nomad, or my scheduler itself, sees some pressure on itself. Okay, I'm running out of resources for the overall group of resources. I'm going to trigger deployment of additional clients. And I'll add more nodes to my cluster, and N be the scale here up to the limits I've set in the platform. And on demand, I've added more capacity. So each node, let's say, has 24 gig of RAM and 4 CPU, right? Added 5 of those nodes. And all of a sudden, my cluster is automatically expanded. This plays really well with auto-scaling groups, ephemeral images, the notion that Nomad can auto-join itself based on tags. And so this becomes a hands-off process. It's like autopilot for you, which is a super way of efficiently managing resources. And if after a period of time you sit under your thresholds, we will take the quiet workers away and make sure that the active jobs are scheduled accordingly and sit on the cluster nicely. So I don't know if that's leveraging those auto scale sets, right? So we support the main cloud's auto scale methodologies. So if that's virtual machine scale sets, instant groups, or auto scale groups, the idea is we can have consistency across my runtime platform. I will cut to this. There's a few questions in there. I'll get to them shortly. I'm going to talk through one of the demos today. So today we're going to talk about dynamic application sizing. So I think everyone's seen an auto scale group before and adjusting scale count. I'm going to go through and do a demo today on dynamic application sizing and talk through how we can take a Nomad cluster that has a Prometheus worker running. It's going to have the Nomad Autoscaler plugin running. We're going to deploy a Redis application. And this Redis application has setting metrics to Prometheus. I'm going to ensure that the dynamic autoscaler will say when certain Prometheus values get to a percentile, I'm going to have that strategy execute and make recommendations on changing or right-sizing this application. I'm going to run a batch job called the load tester, which is a parameterized batch job. It's run a few times to trigger synthetic workloads, or just make the traffic go through the platform, for the logs to come through to Prometheus and the data come out of that to then be seen and trigger the threshold. And then Nomad's going to make a recommendation about what I should be doing with this application. All right, so let's get started. I'm going to just back out of this for a second. We can see here, I'm going to open up Nomad running here on my home lab here. I can see I got a Prometheus job running, the autoscaler, and the load test, and of which I'm just going to adjust this to the right third, last third. Okay, so we got a couple of things here. I can see that I've got an autoscaler on this side here. This demo will be available online afterwards. It is available online now as well as the recording. You can see here I have my autoscaler. It's running. I have some configuration here if I need to do any of the evaluation, but essentially it runs, it does a health check against itself. And I have a Prometheus job running as well, which is running its UI. It will allow me to evaluate anything. It's going to scrape values from Nomad. So I can see here, it's going to take values from the default integration in Nomad, which sends all its information to Prometheus. I can see that I'm cheating here. I'm just statically assigning this IP address here. But essentially, I would normally use Nomad metrics or values and attributes. I can scrape certain configs from the metrics and the agent metrics from the console. And I can then see in my DAS test here, I'm load testing this platform. So I'm going to say I'm going to deploy an application, and I'm going to essentially do a Redis check against it and populate that data, that cache. And what's going to happen here, it's going to trigger the values that are predefined in the autoscaler to then run against the job. And if I look here quickly on my example job, the file that I didn't choose to open, I can see here I have a few things. I have my count of 3 running. They're running on 6379. They're running around Docker. They've got 500 megahertz of CPU and 256 meg of memory. They have a scale evaluation policy. So I'm doing apps. So essentially the 95th percentile. And I'm going to do the evaluation of app sizing max against the memory as well. So if I go into my UI here, and I'll bring this across and just do this for now. I'll just do a clear and then do Nomad job run example. And that's going to run my Nomad jobs here. You'll see here very quickly that my Nomad job will run, and it's running accordingly. It gets scheduled onto my different nodes. You can see my topology here. There's a number of different workers running. I can see my autoscaler is running. I can see that my my cache is spinning up, and it's running now, which is running nicely. Beautiful. Now, you can see the history here. I've run a parameterized job in the past because I like to test my demos and do them live. So I just tested this before. It still does work. But I'm going to run that example job, right? So I remember I cat the DAS load test, right? I can see that's going to run this and execute those parameterized payloads. You can see the metadata here that I've done certain values when you pass through to this. But what I'm going to do now is close on that. I'm going to do Nomad job run DAS load test. I'm going to do that a few times just to generate some traffic, right? You could be using Locust or other tooling here to generate your traffic. If it's a Python application, if it's a Java application, you will have a framework of testing, right? And the idea you could be testing all load balancer connections or the memory or the CPU or a conjunction of all 3. The power of this is we provide you a framework and you can use any APM metrics you like, just super handy. And from here, I will see shortly a recommendation. So you can see here currently, there's a task, the cache load balancer. It's an Nginx process. You can see here over the last period of time that I've run, I'm using, that recommends probably a bit more resources. Looking at here, I have based on my resources here, I recommend reserving a certain amount of resources, but I don't guarantee a number of resources to my container. Here it's saying we recommend the minimum you should give to it is 57 megahertz. So you can see here, based on the load test, or the increase in production traffic or test traffic, I'm seeing about a 14% increase of my recommended overhead. So I can say, okay, you know what? I'm happy with this. I'm looking at here, these allocations. This is great. I'm going to accept this one. And then I look here, and I can see there's another recommendation. Here I have my cached here. So my load balance has been adjusted for resourcing. But my cached here is sitting here going, okay, Burke, you've allocated 1.5 gig of resources, so 3 allocations at 500 megahertz and 56 meg each. There's 3 of these running, but you're only using a very trivial amount, like it's oversubscribed by 90%. So what we're going to recommend, and I don't have to accept this. If I'm happy to oversubscribe some things, I can ask Nomad, ignore this one, right? But I'm going to, you know what, geez, Burke, I'm using a lot here, and I'm using an extra gig of memory, close enough to a gig of memory and 1.5 gig of CPU resources, right? So I'm going to accept this recommendation as well. And what happens here, if I go into this here and go back to my jobs and look at my applications and look at the definition, I'll see that these have been modified accordingly to the job it's running. they get run up accordingly, and their reserve memory values. See now this one here, 57 megahertz. It was 50, it's now 57. So we've ensured now that at a minimum, the applications are getting what they need and no one can take those resources away from them. So it's a really, really nice approach to solving some of these problem spaces. So if I just jump back to my presentation really quickly, the takeaway for this for me, we spoke about straightforward scale, and Nomad does go to solve the 3 scaling paradigms of horizontal scaling, vertical scaling, as well as horizontal cluster scaling. It uses data-driven metrics to drive this scale. And that's a very important part, because these data-driven metrics are what allows us to say the application said X, I'm going to say now do Y, right? And it's not going, oh, you know what, I've got to ask Burke in operations, what does he think? No, the platform's telling me what to do for you, which means if I don't have to, as an operator, it becomes less complex. I don't have to watch it as much. This allows me to start maintaining SLOs, as service level objectives, without human intervention. The application can respond without humans being involved to scale out to cluster additions. And even if you want to automate that with an API to say, I accept these recommendations within a tolerance threshold, which is very trivial with a bit of JQ and API, you can start providing hands-off automation of your platform for applications. And given it's on a per application basis, there might be apps you want to be scaled accordingly, which is super. And that then results in the factor of safety, right? We spoke at the start. This factor of safety results in your higher ups, the people that pay our bills, right, and pay our wages, being happy because applications are using the right amount of resources. You have deterministic budgeting. You're saving money on using cloud resources, as well as providing a better application experience. Right. So HashiCorp, and takeaway from that is that Nomad is uniquely positioned to provide this across all of the clouds, as well as the platforms where you choose to run your applications, be it Java applications, Docker applications, whatever Nomad wants to schedule for you. And with that, I thank you. And I'm just going to check the questions. Yeah, this is currently a feature for enterprise, as Dave said in the chat from Suraj. Dynamic application scaling for horizontal application scaling is an enterprise feature. Horizontal cluster scaling and horizontal application scaling can leverage the autoscale feature, which is part of open source. Just to make sure that is very clear on that one. So dynamic application scaling, which changes the application's reserved resource, is the enterprise feature. The autoscale architecture is open source. Now I'll leave that one with there. Yeah, cool. Something showed, yeah. You'll see that there is a Nomad autoscale enterprise plugin and Nomad autoscale plugin, right? And then essentially the targets you define are limited in the enterprise. If you try to do target an application in the non-enterprise one, it's not going to work. So just to clarify that one there. But with that, Pete, everyone, thank you for your time, and I hand over to Pete.
Thank you, Burke. Oh, great. I was just about to say, can you roll to your last slide? Thanks for that, mate. No, really great presentation and demo. And thanks, Dave, for answering the questions at the back end. Folks, that brings us to the end of our session today. Thanks so much for joining us. If you want to learn, and as Burke might have mentioned, if you want to learn more about Nomad, open source, or enterprise, I encourage you to visit the Learn pages of our website, which you'll find at learn.hashicorp.com. If you do have any questions for Burke after this, just reach out, burke@hashicorp.com. It's quite easy to remember. So yeah, I'm sure he'd be happy to answer any questions you might have. So thanks again for joining us today. Big thanks again, Burke, for the presentation, Dave for answering the questions at the back end, and everyone on this call. Thank you for joining. Enjoy the rest of your day, and hope to see you on another Snapshots soon. Thank you. Bye.